Take a look around you. Everything you see, your phone, your clothes, the glass in the window, even the electricity powering your device, came from a natural resource. Resources are simply things we take from nature and use to meet our needs. We need them for food, warmth, shelter, and to fuel our modern lives. The survival and development of every human society depends entirely on the planet's stock of these materials. Scientists group these resources into three main categories based on what we use them for. We have mineral resources, which are the solid materials we dig out of the ground, like iron for steel or copper for wires. Then there are energy resources, which we burn or capture to generate power, like coal, oil, or sunlight. And finally, the most critical of all is water resources, especially fresh water, which is necessary for all life. If you could magically shrink the earth and roll it around in your hand, you'd quickly notice that the good stuff isn't evenly mixed. This is the concept of uneven distribution. You can see this imbalance everywhere. Some continents are dry and arid, while others are lush and covered in rivers. The reason some countries are rich in oil, while others have to import it, all comes down to where these resources are located. This geographical reality is a major factor in global politics and trade. Why are resources unevenly distributed? It's all thanks to geoscience processes that have been acting over deep geologic time. We're talking millions of years. Imagine the slow, powerful movement of tectonic plates or ancient volcanic eruptions. These processes create the exact conditions necessary to form and concentrate resources. If a region didn't have the right combination of buried life, heat, and pressure millions of years ago, it simply won't have an oil field today. Consider fossil fuels like oil. They didn't just pop up everywhere. To create oil, you need vast amounts of ancient marine organisms and plants to be buried under layers of sediment. Then, over millions of years, heat and pressure from the Earth's interior slowly cook that material into liquid oil. This specific chain of events only happened in certain places, which is why a few areas, like the Persian Gulf or parts of North America, hold the world's largest oil reserves. Metal ores, like the copper used in your phone circuits, tell a different geologic story. They are often linked to volcanic activity and plate collisions. When plates move, magma and superhot water, which is full of dissolved minerals, rise up through the crust. As this water cools, the metals solidify and get trapped in cracks, creating concentrated, valuable deposits. That's why many metal mines are found near areas with a history of volcanic or tectonic action. Even something as common as fresh water is unevenly distributed. In addition to surface water like lakes and rivers, we rely heavily on groundwater stored in underground layers called aquifers. The quality of an aquifer depends entirely on the local geology. Is the rock porous enough to hold water? Is there a layer of clay or rock that traps it? Places with the right kind of underground geology can have access to year-round water, even if they don't get much surface rain. Since we can't just pick up and move to where the resources are, we rely on trade. Think of it like a giant global supply chain. A country that needs copper but has no mines must buy it from a country that does. The flip side is that high population and developed countries are often the biggest consumers, meaning they have to import massive amounts of resources, making them incredibly reliant on the resource-rich regions of the world. The uneven distribution of resources is a major factor in global economics. If a country sits on a huge, valuable resource like high-quality iron ore or vast oil deposits, it can sell that resource globally, generating massive wealth. This resource richness can give that country significant power in international negotiations. This is why control over valuable resource locations like major waterways or rich mineral lands has been a source of conflict throughout history. Most of the resources we just talked about, like metals and fossil fuels, are non-renewable. This means we are consuming them much, much faster than the slow, natural geologic processes can create them. When a mine is completely emptied of its ore, or an oil field runs dry, that resource is gone on any human timescale. Our removal of these resources is actively and profoundly changing their natural distribution on the planet. We have clear evidence that human activity changes the distribution of non-renewable resources. Consider oil. We find a pocket deep underground in the geosphere, drill a hole, and pump it out. We then move it to a refinery, then to gas stations, and eventually burn it. Our action relocates that highly concentrated material, spreading it out or converting it to a gas. The natural reserve that existed is now depleted, and its distribution is permanently altered by our technology. The same phenomenon happens with groundwater, which is technically renewable, but often used up much faster than it can be replaced. When cities and farms rely too heavily on an aquifer, the rate of pumping can exceed the rate of recharge. The effect is a shrinking resource supply. We're essentially digging into the planet's water bank account faster than nature can deposit money back in, causing the regional water distribution to change drastically. A major consequence of uneven distribution and high consumption is water scarcity. For regions that are naturally arid, or where the population has simply grown too large, water becomes a rare and valuable commodity. This forces huge changes in human activity. Farmers can no longer grow certain crops, which affects food supply, and cities have to impose strict limits on water use. Water scarcity can become a humanitarian issue, driving people to search for wetter lands. When a resource is completely used up in a specific location, we call it resource depletion. This has a huge impact on the human communities that relied on it. Imagine a town built around a single copper mine. When the mine runs out of copper, the town's economy collapses. The people who relied on that resource have to move, and the entire country must now look elsewhere to fulfill its copper needs, increasing its reliance on other areas. Because resources are so unevenly spread, many modern nations must live with a high degree of reliance on foreign resources. The US, for example, is a major oil producer, but still imports oil from other countries to meet its immense energy demand. This reliance means that diplomatic relations and global stability become crucial. If trade is interrupted, a country can quickly face shortages of essential materials like energy or minerals. To think like a scientist on this topic, you have to connect the dots. Start with the geologic process, like ancient plate tectonics forming a vein of copper. That copper's location causes the uneven distribution. Then, connect that to the human reliance. Modern life needs copper for electronics. Finally, explain the cause and effect of human removal, which is the permanent change in that copper's concentration and distribution in the geosphere. Technology is a double-edged sword when it comes to resources. On one hand, it allows us to find and extract resources in places we never could before, like deep underwater or in harsh climates. But on the other hand, technology also allows us to use resources much more wisely. Things like more efficient engines, better home insulation, and improved agricultural irrigation all help with conservation, meaning we need to pull less from the ground in the first place. The concept of renewable energy is a direct response to the problem of non-renewable resource depletion. Since we are running out of fossil fuels and they are harmful to the atmosphere, humans are choosing to rely on energy sources that are naturally replenished. Sunlight, wind, geothermal heat, and moving water are all examples of resources that regenerate within our lifetime. Shifting our reliance to these alternatives is key to a sustainable future. So how do we responsibly manage a planet with finite and unevenly distributed resources? We focus on good resource management. This includes simple actions like conservation, being mindful of how much energy and water we use every day. It also includes massive efforts like recycling, where we take used materials like aluminum or steel and process them to create new products, reducing the need for destructive new mining operations. Ultimately, our continued ability to thrive depends on understanding where Earth's resources came from and how quickly we are using them up. The fact that resources are unevenly distributed means global cooperation is a must. By constructing scientific explanations, designing sustainable technologies, and practicing conservation, we can ensure that we meet our current needs while also protecting the resource systems that future generations will depend on.